I'm going to help you with some problems that have to do with ellipse and hyperbola applications. So the first one is a bridge is to be built in the shape of a semi-elliptical arch and is to have a span of 52 feet. The height of the arch at a distance of 24 feet from the center is to be 10 feet. Find the height of the arch at its center. So you'd probably, if you were doing this on your own, you would probably be sketching this on a piece of paper, but just so that it wasn't too sloppy, went ahead and made a graph. It does most with some of this information here. So I decided to center my graph at the origin. If you're ever able to do this, it makes the equation a little bit easier to work with. So with the center at the origin, I can just have a plain x squared and a y squared in the equation, rather than having rather than having a plus or minus something to the x or the y. So my center is at the origin, and then it has a span of 52 feet. So to have a span of 52 feet means I need to go out 26 from each end on the major axis. And I'm going to consider this a major axis right now. I don't know how tall this arch is yet because I haven't solved for it. So I am just going to assume that my A is my larger. I'm going to assume this thing is stretched kind of horizontally. So my larger denominator is going to be my A. And I always put my larger denominator underneath the term where we're stretched that way. So the major axis should be going the same direction as the x-axis. So I'm going to put my bigger denominator under my x term. And that's my distance from the center to the vertices. So I could call each of these my vertices right here and right here. And it's a distance of A away. So I'm going to call A 26 squared. So what I don't know is my B. What I don't know is my B. My B squared should go there. But I do know that my B is the distance from the center to the edge on the minor axis. So if I could figure out the equation of this ellipse, I could figure out what my B is, and that would be the height that it's actually asking. Find the height of the arch right at its center. I've labeled one other point over here, which is 2410, and that is given the information that the height of the arch at a distance of 24 feet from the center, so here's the center. If I go 24 feet over, it's going to have a height of 10, and that's my ordered pair 2410. So what we are going to do is use that ordered pair, the information we do know, because that point falls right on the ellipse, and every point on the ellipse should make the equation of the ellipse true. I'm going to use that point 2410 and plug in my x and my y in the x and y spot of the equation, and then you'll be able to solve for b. So my 24 squared can go in the x spot. So 24 goes in the x spot, 26 down here, my y squared, and then my b squared. Whoops, I don't want y squared. Do I want to replace my y with my y term of the point that satisfies the equation? So I have that equation, and then it just takes a little bit of algebra to solve for b. So without going into too much detail or going through every little step, but I will tell you that 24 squared is 576, 26 squared is 676, 10 squared is 100. So I'd probably do that step first, and then I would slowly move things to the other side and get the b alone. So as I do that, I'm just going to write up here, b squared should equal, as you get all those things and get the b in the numerator. Actually, I will just, you know what, I'm afraid some students might not know how to do that. So let me just go from here. I'm gonna subtract 576 over 676 to the other side. And that'll give me 100 over b squared equals 25. So I'm going to simplify that fraction, and I'll leave that to you. And then from this point, I can do 25b squared equals 169 times 100. I'm going to erase that. 169 times 100 is 16,900. So b squared ends up being 676 if I divide 25 on both sides, which tells me b is 26. So this length here ends up being 26, which makes this ordered pair 0, 26, which makes this b here 26, and maybe you're starting to notice something. Hey, that's what my A was. My B is the same as my A. So it turned out, and you might have noticed visually, this ellipse is actually a circle. and it's just a circle. It's an ellipse, I guess. You could still call it an ellipse in a way, but your A and your B are identical. That means that and that's because it's the radius of the circle. So this thing could have been written in the equation of a circle as well as an ellipse. So that's the height of the arch from its center to its highest point, right at its center. All right, I'm going to go down to this one. It says a hyperbola has asymptotes of y equals 9/7 x minus 1 and y equals negative 9/7 x minus 6. The vertices are 4 units apart and lie on the same vertical line. Find the center of the hyperbola, the distance from the center to the focus, and its eccentricity. So first of all, we've got to think of these asymptotes. And I'm going to write it up here. But think about what the asymptotes do on a hyperbola. They intersect right at the center. That's one of the main things we want to think about with these asymptotes, is they intersect right at the center of the hyperbola. So if I could figure out where these two lines intersect, I would know the center. So what's nice here is that they're kind of set up really nicely. They're two equations. We want to know where they intersect. We're going to solve this system of equations. And it's set up really nicely to use elimination. If you notice, if I add these two together, the coefficients on the x's are already opposite of each other. So they're going to zero out the x's. If I add up the numbers, I'm going to get negative 7. And if I add up the y's, I get 2y. So that allows me to see that 2y equals negative 7, or y equals negative 7 halves, which is the same as negative 3.5. That is my y-coordinate of the intersection. To find the x-coordinate, I could take that negative 3.5 and plug it back into either one of the equations. If I do it in the first one, negative 3.5, or I could use 7 halves, negative 7 halves. 7x minus 1. I'm going to solve for x. I'll skip a few of these steps, but hopefully you'll be able to solve for x here. X is going to be equal to negative 35/18, which is the same thing about as negative 1.944. So I've found my center, or the intersection of these. Negative 35/18 is the x-coordinate, and negative 7 halves is the y-coordinate of my center, or my intersection. So down here I've put the graph on here of my center. So you notice these are in decimal form. Negative 1.944 and negative 3.5, but that is my center right here where the two lines end up crossing. So there's my asymptotes. Remember how the asymptotes helped us with a rectangle? We usually drew the rectangle first and then that helped us place our asymptotes when we were graphing hyperbolas. So I kind of just drew in red here this little rectangle that goes through that is centered about the center, and the corners of the rectangles where my asymptotes go through. I also wrote some other things up here because of what we were given. We were told that the vertices were 4 units apart on a vertical line. We know vertices have to be centered with the center, and so that told me that these two vertices were right above the center and below the center. And so I counted, to have a total distance of 4 units here, I counted 2 up and 2 down. I labeled this point, but I didn't label the other one, so let me write that on there. Negative 1.944, and then the height of that one, we would take the height of negative 3.5 and I'd subtract 2 from it, so negative 5.5. So that gives us a distance between the two of 4. That tells me something, because the distance from the center to the vertex should be my A. It should be my A, and what I call A on my equation of the hyperbola. So if A is 2, A would need to be 2 to have the total distance between the two vertices before, right? So let's start writing our equation of this hyperbola. Remember, that's a minus between the two fractions with hyperbolas, equal to 1. With hyperbolas, we want to know which way the branches are opening to tell us which fraction has which fraction is my positive fraction, which fraction is my negative fraction. So since these branches are opening upwards, they should be opening upwards and downwards. That means my transverse axis, the axis that contains all the major points, is going to also be going upwards, just like the y-axis goes upwards and up and down. So that tells me my y-coordinate should be my y term should be my first positive fraction. and my x term should be my second fraction. So it's the one that's negative. And so I always call whatever the denominator of the first fraction is, I will call it a. The denominator of the second fraction, b, with hyperbolas. So now that I know my center, I'm going to erase my h and my k, and I can put my center in there. My center, I'll just use the decimals, but let's see, and I'm going to have to squeeze it in there. Negative 1.944. So since it's a negative 1.944 and we're subtracting it, I'm going to end up making this a plus sign here. 1.944. And over here, my y-coordinate of the center is negative 3.5. So I'm going to end up adding, because I'm going to be subtracting a negative, 3.5. So I've got those in there. I also know my a, because we saw that 2 units away was my a, so I could put my 2 in there. So again, on this one, I just need to know what my b is. I need to know what my b is. Now, if a is 2, I mean, how am I going to find out my b? B is the distance from the center to the edge of this box going the other way. Well, I do know the slope of my line. Notice how the slope of the line here should be a over b. Rise over run. A, up A, and O over B. That should be the slope of my line. So if I scroll up here, I've already written a few things down. A over B is my slope. I also know my slope, something about my slope from the equations of the lines. 9 over 7 is my slope. So it seems like A should be 9 and B should be 7. But wait a minute, we just said A was 2. Down here, right? We said A was 2. So how can A be 9 and A be 2? Well, we can write fractions different ways. So the slope could be 9/7. 9/7 is the same as 18/14, right? 9/7 is the same as 27 over 21. There's lots of different ways to write 9/7. We're just being asked to write 9/7 in a way where the numerator is 2 and find out what b needs to be if the numerator is 2. So I'm going to let 9/7 be equal to 2 over b because I need to know what b needs to be if the numerator is 2. And that allows me to solve for b, knowing the slope. So I'm going to take 9 times b and equal it to 7 times 2. Divide by 9 on both sides. So b needs to be 14/9. B needs to be 14/9. And if I take this and put my b in there, that told us b needs to be 14/9. I can put my b right here, 14/9. That should be the equation of my hyperbola. And let me flip over my screen. Over here, I've already typed it in. I used 3.5 instead of 7/2, but that's the same thing. I've put all of this in, and as I let it show up on the screen, you can see it makes us happy because you can see it does go right through the vertices and heads right towards those asymptotes on the screen. So that is the equation of the ellipse. So how are we, or the hyperbola. So how are we then going to answer the few other things it asked? It asked for the center. We found that. Center was right here. It asked for the distance from the center to the focus. So the distance from the center to the focus, that's something we haven't talked about yet. The focus should always be squeezed inside of these branches. So the focus has got to be somewhere inside of those branches here. A point that's right in line with the center, with the vertex, and there's the focus. The focus should be a distance of c away. So the distance from here to here, center to the focus, should be a c units away. But there's no c in my equation. Over here, there's no c. There was a, there was a b, there was the x term, h and the k, y term, but there was no c. But what we can do is use this relationship here between a, b, and c. This is always true for hyperbolas. It's a squared plus b squared equals c squared. So if I know my a is 2 and I know my b is 14/9, I can find my c by this relationship. So as I add these up, I get 6.419753. I square root to get rid of the square, and I get c equals 2.5337. And so that is the final answer on that, what it's asking. The distance from the center to the focus should be about 2.53 units away. The eccentricity I'll let you do, but I did put the formula down here. We usually talk about eccentricity with ellipses, but they did ask it for the hyperbola here, so we're going to use that same formula. And you could take the distance from the center to the focus, which was this 2.5337, and divide it with the distance from the center to the vertex, which was 2. And I'll leave that to you. Hopefully this helped, and send me any other questions you have. Thanks.